I'm Anil Kumar. Let me thank all the viewers and subscribers for posting their request. This video is especially for those who are preparing hard for their board examination class 10. I've picked a few questions from previous test papers. Let's discuss how to solve trigonometry problems or applications where height and distance is involved. So we have 4 different types of questions. Let us see how to work with these. Question number 1. Teresa is at top of her apartment building and is looking down at her friend Anna at a 50-degree angle of depression. The horizontal distance from the base of the building to Anna is 16 meters. Determine the vertical height of the building. So first part always is to sketch a diagram, right? So let's say that is the building, correct? And we know Teresa is at the top of the building and she is looking at her friend Anna. So let's say this is the line of sight. Now the first question is, the angle of depression is 50 degrees. What does that mean? Now from here, the angle of depression is always measured from horizontal line, right? So this angle is 50 degrees. Is that clear to you? If you make a mistake here, then you get definitely a wrong answer. Now let's fill in other details. Anna is 16 meters. So this distance here is 16 meters. Let's say A, and let's say T, and let's say this is O. Determine the vertical height of the building. That is what we need to find. Now, these two lines, that is horizontal line, this is also horizontal line. So these two lines are parallel. So you see a Z pattern. Therefore, this angle should also be 50 degrees. Now in this particular triangle, as you can see, what we know here is the adjacent side, since this is 90 degrees, right? Building is straight. And we want to know T to O, the height of the building, correct? So they are related with tan ratio. So we can write down tan of 50 degrees is equal to TO over OA, right? So OA is 16. So from this relation, we can easily find what the height of the building TO is, right? So TO is the height of the building, correct? So we can just cross multiply and say the height H, which is equal to T to O distance, is 16 times tan of 50 degrees. Is that clear? Sometimes in these questions, they will tell you to round answers to 1 decimal place, something like this. So in that case, you need to round your answers also. Now let us see what do we get. We get 19.06. So that is fair enough. 19.06. You can easily write 19. And do not forget to include units. This distance is given in meters and therefore it is 19 meters. And the answer should be written as height of the building. The building is 19 meters. Now all these are very important steps, correct, whenever you are solving such questions. So what we learned here is that tan ratio, so we know tan of an angle theta is equals to opposite over adjacent side, right? And second thing which we learned is always angle of elevation is from the horizontal, or angle of depression is from horizontal, right? So angle from horizontal. Okay, so let's move on and see question number 2 now. Question number 2. An airplane flying at a height of 3125 meters from the ground passes vertically below another plane at an instant when the angles of elevation to the two planes from the same point on the ground are 30 degrees and 60 degrees respectively. Find the distance between the two planes. Now in this particular case, we are given that there are two planes, right? So let's say this is our ground. Now these two planes are at different height, but one above the other, right? So let's join these points. Correct. So which plane are we talking about? An airplane, when flying at a height of 3125 meters from the ground, passes vertically below. So this plane, we'll call this plane as A, and this particular height is 3125 meters. Is that clear? The other plane is B, which is on the top of it. The angles are 30 and 60 degrees, so this angle will become 30 degrees, and the bigger angle will become 60 degrees. Correct. So that is how we get our figure. We need to find what? We need to find the distance between A and B. Let's call this distance D. So find the distance between the two planes. Now how are you going to do it? Right? So that is what you need to figure out. Now in this particular case, we can find the tan ratio, right, and then subtract one height from the other to get the particular answer. And we know that this height from ground to position A is 3125. So the first part will help us to find the distance along the base, right? So let's say this distance x we can find first, correct? So using a smaller triangle, let's call this point as P and this as O, right? So first let us solve the triangle APO. Now in this particular triangle, you can use tan 30. So we can use the tan ratios. We can say the tan of 30 degrees is equal to the opposite side over x, which is 3125 over x, correct? So we can cross multiply and get the value of x, which is 3125 divided by tan of 30 degrees. Now, many times calculator is not allowed. So let me just give you the special triangle also while we are working on it. So I prefer to draw one triangle for both sine and for both 60 and 30 degrees. So in this triangle, this angle is 60 degrees. This is a right triangle. So here we have 30 degrees. The sides are in the ratio of 1:2 is to square root 3. Square root 3 can be taken as 1.7 for most of the calculations. Okay. So if calculator is not allowed, you could do that. Otherwise, use your calculator. Perfect. So tan of 30 will be 1 over square root 3. Good. So you can find the answer using this particular thing. Right. Now, we'll use the calculator at present to find the distance x. So we have 3125 divided by tan of 30 degrees. And that gives you 5412.65. Okay, so all the units are in meters. Perfect. So that gives you 5412.65 as the distance between P to O. Now, when we know this distance, we can find the height B from O and then take away 3125 to get our answer. Is that clear? So now we will solve the triangle, the bigger triangle, ABO, right? Now where, again, we'll use the tan ratio. So this time it is tan 60. So we have tan of 60 equals to B to O, right, over x. And x we just calculated as 5412.65, correct? So that gives you the value of total height BO, right? So we'll just divide this page and then write the calculation. Here BO is equal to 5412.65 times tan of 60 degrees, correct? So let's calculate. We already have 5412.65 in the calculator. We'll multiply this by tan of 60 degrees to get the answer as 9375. So we get this value as 9375, correct? So we found that this height, total height, is 9375. Perfect. So what is the difference between the height of the two planes? So we can find BA as 9375, take away 3125. Is that clear, right? So that gives you the answer straight away, right? So it is 6250 meters. So the answer is 6250 meters. Is that clear? So that is how you're going to do this question. Now this question has been repeated a couple of years, so it is the most expected question in your test paper. I hope that helps. Let's move on and take question number 3. Question number 3. There are two poles, one on either bank of a river, just opposite to each other. One pole is 60 meters high. From the top of this pole, the angle of depression to the top and the foot of the other pole is 30 degrees and 60 degrees respectively. Find the width of the river and the height of the other pole. So let's sketch. Let's say this is the river. Okay, so this is the river in between, and let me sketch the poles. So this is one pole here. The other pole is on the other side. So let me draw a line here. So let's say this is the other pole. Okay, and the line of sight is kind of like this. Now what are we given? We are given that the angle of depression is 30 and 60 degrees. So as we discussed, that angle is always from the horizontal. So this is 30 degrees for the top, and this angle here is 60 degrees. Correct? Now we need to find the height of the pole. So let me just name the first pole as AB and the other one as CD. We also need to find the width of this river, right? So this is the river flowing, so we need to find the width of this river also, correct? And what else are we given? We are given that the two poles are on either side, just opposite to each other. Pole is 60 meters high, so we are also given that this height is 60 meters. That makes sense. Now let's solve the bigger triangle, in this triangle ABC, to find the width. This angle is 60 degrees, so therefore that angle should also be 60 degrees. Correct? So from here we'll get the width using tan ratio, right? So if a tan of 60 degrees is equal to 60, the opposite side, right, which is 60, over the adjacent side AC, right? So we'll say AC at present. So just cross multiply. So AC is equal to 60 over tan 60. Correct? You know this special triangle, so you could use square root 3, but we'll use the calculator for the time being. So we have 60 divided by tan of 60 degrees to get the answer, which is, let's write in decimals, 34.664. So let's say we are assuming to round them in one decimal place, so I'll write this as 34.6 as my width, right? Now, we need to find the height of the pole. Now, how do I get the height of the pole? So to get the height of the pole, let's construct this. So we draw a horizontal line, right? So this is D dash, same level. Now in this small triangle, that angle is 30 degrees, correct? That Z pattern. So let me label this as D dash. So now we are looking into a smaller triangle, which is the triangle BD dash. So we are looking into the triangle BD dash, correct? The top one. Now here we can find BD dash using 30 degrees, and we know the width is 34.64. Again, tan ratio, right? Tan is opposite over adjacent side. In this case, the angle here is 30 degrees. So that angle with tan will give you B to D dash divided by the width, which is, we'll write 34.64. So BD dash is equal to 34.64 times tan of 30 degrees. Correct? So let's calculate. So we already have 34.64 in the calculator. We'll multiply this by tan of 30 degrees. Right? So it is good to keep these values in the calculator since it saves time. Do you see that? So we get 20. So this B to D dash is 20 meters, correct? And we know that the height is 60 meters in all, right? So C to D is basically equal to A to D dash, right? Which should be equal to 60 meters minus 20 meters, and that gives you 40 meters as your height of this particular the other pole, right? So we got all the answers. So answer here is width of the river is 34.6 meters and height equals to 40 meters, height of other pole, right? So that is how you're going to solve it. So I hope that makes sense. Let's move on and take the next question now. Here is the last question, question number 4. Anil is flying a kite and has let out the entire 150-meter ball of kite string. He notices that this string forms a 60-degree angle with the ground. Sam is on the other side of the kite and sights the kite at an angle of elevation of 30 degrees. How far is Sam from Anil? So, most of the time we have been using tan ratio, but that is not always true. You'll notice this time. Now, we have a kite somewhere here, right? So that is the kite flying, and what we are given here is that Anil has let out the whole thread, and this distance is 150 meters, right? So that is the distance given to us this time. And on the other side, we have Sam, and for Sam, the angle of elevation is 30 degrees. So this angle here actually is 60 degrees, let's say Anil, right? For Sam, it is 30 degrees. I don't really have much space, so it'll look like similar. Okay. These drawings definitely are not to the scale, right? So don't get confused. So Sam is on the other side of the kite and sights the kite at an angle of elevation. So whenever we talk about angle of elevation, it is always with the horizontal, right? So both are with the horizontal, correct? So this is the situation. What do you need to find? How far is Sam from Anil? So this time we need to find the distance between Sam and Anil, right? So we want to find this distance. So how will you find this distance? That is your question. So you can actually pause the video, answer this question, and then look into my suggestions. Let me label this A, K, and S. A for Anil, K for kite, and S for Sam. So how can we do this particular question? Okay. So one of the ways to do is that we could actually drop a perpendicular from here, and we can find height of the kite using tan ratio, correct? So if I do, now using which ratio, you need to figure it out. So if I work in the triangle AK, let's say this point is P, okay. So we'll do triangle AKP. Now in this triangle, what do you notice? This is right angle. We have opposite side to 60 and hypotenuse, right? So we are going to use sine ratio this time. So we use sine of 60 degrees, which is the ratio of opposite side to hypotenuse, correct? So most of the time, when you work with high distance questions, you're always working with tan ratio, but that's not necessary. Therefore, I've taken this question, right? So hypotenuse is involved, we'll take sine ratio. So sine 60 is equal to height h over 150. So from here, we can get the value of height, which is cross multiply 150 times sine 60 degrees, correct? So let's calculate this answer. So it is 150 times sine of 60 degrees, which gives you, let's write decimal values, approximately 130. So we get 130, so we'll approximate it to the whole number, 130 meters. So this height is 130 for us. Once we know the height, we can solve both these triangles now and also find the distance between the two. You get the idea, right? So now we can use the tan ratio to find the distances. So A to P, we could again continue with this triangle and find what A to P is, right? We know the height also. Anyway, height was necessary for the second triangle. Let me be clear about it. But let's find. So now we say tan of 60 degrees should be equal to 130. Actually, you could use cosine, right? So let me not use tan 60. We'll find AP using cos, correct? So we can say cos of 60 degrees is equal to adjacent side, which is AP, over hypotenuse, which is AK, correct? So that means we don't know what AP is, so we can find AP as AK 150, which is correct, times cos of 60 degrees. So let's find this. So we do 150 times cos of 60 degrees equal to 75, right? So we get this value as 75 meters. So this height here, this distance here is 75. We solve this using cosine ratio. Perfect. Okay. Now let's get to the next triangle, which is triangle K, P, and S. Now we just need to find P to S. So these two are opposite and adjacent. We'll use tan, right? So in this case, we'll use tan ratio. So we'll say tan of 30 degrees is equal to opposite side, which is 130, divided by P to S, which we need to find. So this gives you P to S is equal to cross multiply 130 over tan of 30. Okay, let's calculate this now. So 130 divided by tan of 30 degrees, which is 225.16. So we'll round it to 225. Is that okay? So this is 225, the other one is 75, and therefore the total distance, so total distance between them is how much? We have to add these two, so we add 75 with 225, correct? So that is 300. 300, and the units are, since we are given this in meters, the units will be 300 meters. Does it make sense to you? So that is how we are going to solve this particular question, correct? So I hope the concept is clear, and we have seen what angle of elevation and depression is, always measured from the horizontal, and we have also learned with the help of our last example that you might use sine ratio or cosine ratio to solve height and distance problems. However, most of the time, since we are involving height and the distance, it is most of the time tan ratio. Perfect. So that brings us to the end of this particular video. That should help you to perform better for your board examination. All the best. Share my videos with your friends, and if you have questions, feel free to post them. Thank you, and all the best.